We're about ready to get started. Okay, so welcome back, everyone. Hope you are all doing well with this semester. Today we're going to be talking about GPU architecture. So who here can tell me what a GPU is or what it stands for? I don't heard it, but anyone else? You know? Yeah, yeah, exactly. It's a graphics processing unit. So chances are, whatever computer you use, whether it's a desktop or a laptop or even your phone, it has some sort of GPU in it. They're also called graphics cards sometimes. And the GPU has a lot of applications. So, I mean, in the modern day, it's used for just about everything. Whether you're watching a YouTube video or editing videos, playing a game, even doing an AI project, GPUs come in handy. So, I'm going to tell you guys a little bit about GPUs, kind of how they started to be a thing, what you can do with them, and also how they work inside. So, as Leland said before, a GPU or graphics processing unit, sometimes known as a graphics card, is just a special piece of computer hardware, and it's kind of like a CPU or central processing unit, except that it differs in that it can only perform certain types of calculations. So a CPU can calculate just about anything. If you put any sort of program into it, you can just run it. But GPUs can't really be used to run most programs. Instead, they have things called CUDA cores, which can do some like linear algebra math, like y equals mx plus b, that kind of thing, and it does it really fast. And well, the reason that they're useful is that it can do thousands of these at the same time, whereas a computer can only do, or a CPU can only do like 5 or 10 things at a time. So yeah, it allows for a lot more scale, a lot more efficiency, and a lot of different tasks. So let's talk about some of the applications of GPUs. So who here has ever played a video game at any point in their life? Yeah, pretty much all of you. So whatever video game you play, whether it's Minecraft, Red Dead Redemption, Cyberpunk, or even like a mobile game, all of them are going to use a GPU in some way. So you might have heard of certain games that are kind of not playable unless you have a really expensive gaming PC. Well, most of that cost is the GPU. In fact, a modern GPU for the top of the line costs around $2,500. So, I mean, that's more than most gaming PCs cost in general. But you can find a few as low as just a few $100s, or even less if you're on a budget. So, yeah, it's very big for gaming. If you want to play some games with 4K resolution and like ray tracing and stuff, it really helps to have a good GPU. But it's an investment. Yeah, then you can also use it for video editing applications, which kind of works in the same way. It's just like rendering stuff. And similarly, 3D rendering software like Blender, SolidWorks, or even Autodesk Inventor, they all use GPUs because they involve 3D rendering of objects, and it makes the math a lot quicker for the computer. Now, cryptocurrency and blockchain are also really popular application of GPUs these days. Uh, so, has anyone here heard of Bitcoin mining before, or any sort of crypto mining? Few years back. Yeah, so basically the way cryptocurrencies work is they're on a platform called the blockchain that works by having individual users basically have GPUs that just do a bunch of math problems like constantly forever. And if they get the math problems right, they get little pieces of Bitcoin for free, and then that's money. So yeah, people can basically use GPUs to generate cryptocurrency, which is also just how the blockchain runs. So all cryptocurrencies depends on GPUs. And of course, uh, in my opinion, my favorite application of GPUs is with AI and machine learning. So whether you're training or actually using an AI model, it uses a lot of GPU power. And the reason for this is because AI is just repeatedly doing trillions and trillions of calculations that are very simple. So a normal CPU will take a long time to do these calculations because it's not optimized for those specific tasks. But a GPU has special components built in that are just for handling those types of AI tasks. Uh, One example of this is a tensor core, which is a new thing NVIDIA has been using, which can directly multiply different matrices together with up to, I think, like before in each dimension. So normally, if any of you've taken linear algebra, if you want to multiply two matrices, it's a lot of multiplying two numbers over and over. But they've made special cores, special parts of the GPU that can calculate that whole thing all in one instant, which just makes the whole thing a lot faster. And in AI, a lot of stuff like with convolutional neural networks is just multiplying a bunch of matrices together. So yeah, it really accelerates stuff. Yeah, AI and machine learning would not be anywhere near where it is today without the help of GPUs. So let's talk about a brief history. You can see up here in the corner, very 1990s style box of a GeForce 256 GPU. So that's kind of like the really old gaming stuff from the 90s. But even before that, GPUs actually were starting to become a thing in the 1970s before computers were even popular. And at that time, it was just an experimental piece of hardware to help with video rendering. And actually, some old arcade games like Pac-Man had their own early versions of GPUs built in to help with certain rendering tasks. So in the 1980s and 1990s, people started to realize that GPUs were good for more than just playing Pac-Man. You could actually use them for a lot of things in your personal computers. So they started designing things like, as I mentioned, GeForce 256, which is a really early NVIDIA graphics card. And that could help with video rendering or even playing video games on your personal PC, which was a huge revolution at the time. Because until then, computer was just a little terminal that you could type into and it gives you something back. It was not very sophisticated. So playing video games in the comfort of your own home was a big change. In the 2000s, things started kicking off. Gaming became a bit more popular. G, uh, the GeForce and Radeon series both became pretty popular, and those are actually still the leaders in GPUs today, GeForce and Radeon. So yeah, and also people started to realize around this time that it can make machine learning, statistical applications, and even doing science work. It could be a lot faster with GPUs. Now in the 2010s, a lot more GPUs started becoming prominent, and at this point, about 90% of new computers have a GPU in them, compared to almost none of them in the 80s and 90s when they were first invented. So it's a very big revolution there. Pretty much can't buy a computer now that does not have a GPU, especially today, where they're now the norm for AI, blockchain, a whole bunch of other stuff, video games especially. So yeah, GPUs are a big deal. You see over here the 5090. That's NVIDIA's brand new card from just last month. Again, that one costs $2,500, which is an insane amount of money, but it is extremely good. It'll crush anything you throw at it. So, yeah. Any questions so far? Does anyone have a gaming graphics card? Kurt, do you have one? No? Dang, that's fair. They're really expensive. Yeah. All right. Now, if you're wondering how graphics cards actually work, we have a video here that kind of explains some of the architecture much better than I ever could because I'm not really a computer architecture kind of guy.